In this video, we will continue practicing solving trig equations like this one. This is the second video in the series. We've already solved problems 1 through 5, so if you missed that, go back and check it out. Now, we already have 0 on one side, so let's go ahead and factor this. This looks like it's going to be factorable. So I'm going to set up for a binomial times a binomial. 2 sine squared x can only factor as 2 sine x times sine x. Now I skip over and look at the 3. Ignore the negative sign for a minute. 3 can only factor as 3 times 1. Now it matters whether or not the 3 goes here and the 1 goes here, or vice versa. The way I know which one works, inner plus outer must equal the middle. So inner, I have 3 sine x. Okay, inner. Outer, talking about these two, that's 2 sine x. Now the middle is negative 1 sine x. I can get negative 1 out of this if I let the first one be negative 3 sine x and the second one be positive 2. That'll make negative 1. So negative 3 goes here, and for positive 2, I need this to be positive. Also, negative 3 times positive 1 equals negative 3. So this is the way it has to be. So now that we have factored it, we can use the zero product property and set each one of these factors equal to 0. So on the left side, 2 sine x minus 3 equals 0, or sine x plus 1 equals 0. We're going to solve each of these. So here I'm going to add 3 to both sides, so that gives me 2 sine x is equal to 3, and then I'm going to divide by 2. So those cancel each other out. So now I'm going to have sine x is equal to 3 over 2. Now, just to make it more clear, I'm going to write this as a decimal. 3 over 2 is 1.5. So I'm asking myself, the sine of what angle is 1.5? And right away, I know that this is going to be no solution. No solution. Because looking at the unit circle, okay, looking at the unit circle to help focus our brains, all right, the sine function is the y value on the unit circle. So the highest y value is going to occur right here, all right, at 0, 1. All right, there's no y value higher than this. This is the top of the mountain. So there is no sine value that's going to get up to 1.5. So that's why this is no solution. All right, meanwhile, on the other half of the equation, maybe we'll find a solution over there. So let's subtract 1 from both sides. So now I have sine x is equal to negative 1. Okay, so the sine of what angle is equal to negative 1? Well, let's draw our diagram. This is seeming like it's going to be a quadrantal angle. In other words, over here I have the point 1, 0, and then at the top I have 0, 1. On the left I have negative 1, 0. At the bottom I have 0, negative 1. On the unit circle, the sine function is the y value. So I'm looking for a y value that is negative 1. No, 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 yes. Boom! So this angle that gives us a sine of negative 1, this has to be the solution. So, of course, that is 3 pi over 2 right here. All right, so that's it. X is equal to 3 pi over 2, only one solution. Okay, so take a look at number 7. Notice that we have a sine and a cosine. we're not going to be able to solve the problem as long as it has two different kinds of trig functions. So we have to do something about that. Now, on a previous lesson, we've learned about the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and then all of the variations that we can get by subtracting different things. So if you have never seen this, go back and find the video about the Pythagorean identity and simplifying trig functions. But the bottom line is you should be able to generate this chart in about a minute and a half. And then, so I'm going to just refer back to this chart. So we can use these identities to convert back and forth between sine and cosine and secant and tangent, etc. So in this case, I see sine squared x right here. So looking on my notes, I see that sine squared theta is equal to 1 minus cosine squared theta. So I should be able to make that substitution here. So instead of sine squared x, I should be able to put 1 minus cosine squared x. All right, I've just made that substitution here. Now I've still got this 2 out front, and then the rest of the problem. 3 cosine x minus 3 equals 0. Now I have all cosine, and this should be a doable problem. So of course I'm going to distribute this 2, so that will become 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. I've got some like terms here. All right, the 2 and the negative 3 are like terms. So I put them together. So now I have negative 2 cosine squared x plus 3 cosine x. 2 and negative 3 together make negative 1, and that's equal to 0. Now, I want to factor this, but I don't like factoring when there is a negative in front. So I will handle that by dividing everything by negative 1. So that just will have the result of changing all the signs. So this will become 2 cosine squared x minus 3 cosine x plus 1. Ah, that's better. So this is what I will now factor. So let's go for binomial times a binomial. 2 cosine squared x can only factor as 2 cosine x times cosine x. 1 can only factor as 1 times 1. Inner plus outer must equal middle. All right, inner, I have 1 cosine x. Outer, I have 2 cosine x. I'm trying to get a middle of negative 3 cosine x. I will get negative 3 if both of these are negative. So that means this is negative and this is negative. Also, checking one more thing, negative 1 times negative 1 is positive 1, so it works. So we have now factored the original trinomial. So now we can use the zero product property and set each of these factors equal to 0 to find the solutions. So I will have 2 cosine x minus 1 equals 0, and I will have cosine x minus 1 equals 0. Adding 1 to both sides, that gives me 2 cosine x is equal to, that's cosine, 2 cosine x is equal to 1. And then dividing both sides by 2, that leaves me with cosine x is equal to 1/2. So, what is the angle? So cosine of what angle is 1/2? Well, this is one of the facts we should have memorized. Cosine of pi over 3 is 1/2. All right, that tells me that the reference angle is pi over 3. All right, that is not necessarily the solution or the only solution. It's the reference angle. So fine, the reference angle is pi over 3. So I will draw myself some pi over 3s. So here's a diagram of pi over 3s. there are 4 angles that have a reference angle of pi over 3. They are here, 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 and here. 2 of these will give me positive 1/2, and 2 of them will give me negative 1/2. Cosine is an x value on the unit circle, so it will be positive on the right and negative on the left. In this case, we want positive 1/2, so we want these 2 solutions on the right. Okay, which is why the answers are x equals pi over 3 or 5 pi over 3. All right, we have pi over 3, 5 pi over 3. So we have those 2 solutions so far. Okay, I guess I might as well put a box around that. But we may get more solutions from the other side. So coming over here, if I add 1 to both sides, now I have the cosine of x is equal to 1. Okay, so what angle has a cosine of 1? Let's draw a diagram. This is looking like it's going to be a quadrantal angle. So this is the point 1, 0. Here we have 0, 1. On the left we have negative 1, 0. And at the bottom we have 0, negative 1. Now on the unit circle, cosine is the x value. So we want the x value to be 1. So I see that here, and no, no, no. This is it. So this is the only angle that has a cosine of 1. Okay, and so that means x equals 0. This is angle 0. So we have 3 solutions: pi over 3, 5 pi over 3, and 0 for number 7, right? Okay, let's keep going and do number 8. Okay, here again, I see 2 different types of trig functions, secant and tangent. So one way to turn this into all one trig function is to use our Pythagorean identities. Secant squared x. That looks like the type of thing that would show up on this chart. And here it is right here. Secant squared is 1 plus tangent squared. So I should be able to make that substitution. All right, so I'm going to replace this with 1 plus tangent squared. So I've got 1 plus tangent squared x. Okay, that's this. And then I still have the rest of this. Minus 2 tangent x is equal to 4. All right. Now, I need 0 on one side, so I'm going to subtract 4 from both sides. Notice that these are like terms. So I'm going to rewrite this. Of course, this makes negative 3, but I'm going to put that negative 3 at the end. So bringing this down, I've got tangent squared x, and then negative 2 tangent x, and then because of this, minus 3 is equal to 0. This looks like it will be factorable. So let's go ahead and shoot for binomial times a binomial. Tangent squared x can only factor as tangent x times tangent x. 3 can only factor as 3 times 1. Inner plus outer must equal middle. Inner, I have 3 tangent x. Outer, I have 1 tangent x. I'm trying to get a middle of negative 2. That will happen if I have a negative 3 and a positive 1. So negative 3 and positive 1. Checking one more thing. Negative 3 times positive 1 does give you negative 3. So we have now factored correctly. So we can find 2 solutions by setting each of these factors equal to 0. It's called the zero product property. So tangent x minus 3 equals 0, and tangent x plus 1 is equal to 0. All right, over here I've got tangent x is equal to 3. And over here, subtracting 1 from both sides, I've got tangent x is equal to -1. Now, I'm going to come back to the one on the left for a minute because honestly, I'm not 100% sure what to do with that without involving a calculator. But this one, I know what to do because I know the angle. The tangent of what angle will equal 1? Ignore the negative for a minute. So remembering our notes, all right, that we should have memorized by now, tangent of pi over 4 is equal to 1. That tells me that the reference angle here is pi over 4. Okay, so I'm dealing with a reference angle of pi over 4. So I will draw a picture, a diagram of pi over 4. So there's pi over 2, and here comes pi over 4. All right, there are 4 angles here that have a reference angle of pi over 4. They are here, 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 and here. The tangent of any of these will give me some kind of pi over 4. It's just that 2 of them will be positive and 2 of them will be negative. Okay, in this case we want tangent to equal -1, so that's why the solutions are here and here. So great, we have 2 solutions so far. X is equal to 3 pi over 4 or 4, 5, 7 pi over 4. Okay, so from this equation we get these 2 solutions. So now, the tangent of what angle is equal to 3? Now, looking at the left side, tangent x equals 3. I do not see a way to do this without a calculator. And later, if I figure out how to do it without a calculator, I will come back and show you. But for now, I'm going to break down and use a calculator. So, if I want to find the angle, right, the tangent of what angle is equal to 3, then the angle whose tangent is 3, I'm talking about an inverse trig function. So if I want to find the angle should equal the inverse tangent of 3. Okay, so I'm going to use my calculator to figure out what that is. Before I do that, everything else we've done so far has been in radians. You know, 3 pi over 4, this is all radians. So let's make sure our calculator is in radian mode and not degree mode. All right, let's be consistent. So here we are in radian mode. So I'm going to do inverse tangent of 3. Okay, so rounded to the nearest hundredth, this would be 1.25 radians. Okay, so look, so that's one solution. So I have x is equal to 1.25 radians. But let's draw a diagram because there is another solution. Just like we had 2 solutions here, we're going to have 2 solutions for this side as well. Okay, so just for reference, let me put some decimals on here. Up here at the top, we know that this is pi over 2. But what is that as a decimal? Let's see, where is pi? Up there it is. So pi divided by 2. All right, so 1.57. So this is 1.57 right here at the top. So 1.25 is, you know, somewhere, something like here, let's say. All right, this is our 1.25. Okay, and so this is a reference angle. of 1.25. Now there are 4 places on this diagram that will have a reference angle of 1.25. Okay? It's also, we will have that same reference angle of 1.25 here. Okay, if I let this be 1.25. And we'll have also that same reference angle if I put it here. And we will also have that same reference angle if I go here. Okay, so all 4 of these angles have a reference angle of 1.25, assuming that I'm drawing them all so that they are 1.25. But tangent is positive in the first and the third quadrant, and tangent is negative in the second and fourth quadrants. So in this case, we wanted a positive result. So we need to stick to the first and third quadrant. So we can forget about these green ones. So the other solution is going to be here in the third quadrant. But how do I find the decimal for that? Okay, now keeping in mind that the reference angle is 1.25. Okay, so this reference angle has a size of 1.25. Now right here, we're at pi. So if I'm going to go from here to here, it's going to be pi plus the reference angle, all right? It's increasing by the reference angle of 1.25. And that should give me the value of this angle where it lands. So the question is, what's pi plus 1.25? Because that should be the final answer. Okay, so let's do that. If I do pi plus 1.25, I get 4.39. Okay, so in decimal form, these are the 2 solutions from this side. So put it all together, and we have 4 solutions. Now, if there's a way to do that without a calculator, I haven't figured that out yet. I'll get back to you. All right, this video is getting pretty long, but I'm going to go ahead and squeeze in one more problem. The one thing I cannot do is divide both sides by a trig function. All right, do not go like this and say, oh, I'm just going to divide both sides by cosine theta. The reason why is sometimes that trig function is 0. So partially you're dividing by 0, and that breaks the universe. So we can't do that. Instead, we are going to subtract cosine theta from both sides. All right, so that's going to give us cosine cubed theta minus cosine theta is equal to 0. Now, cosine is a common factor here, so I'm going to take cosine out. So if I do that, that's going to give me cosine theta out in front. And then inside, I will have cosine squared minus 1. Now, hopefully you're noticing that this is the difference of 2 squares. So we can factor this further. So I'm going to keep the cosine theta out in the front, but this will factor further as cosine, I forgot the theta. Cosine theta plus 1 times cosine theta minus 1. So I have 3 factors. Now I'm going to use the zero product property and set all 3 of these equal to 0. So here I have cosine theta is equal to 0. And here I have cosine theta plus 1 is equal to 0. And cosine theta minus 1 is equal to 0. This is already solved, but over here I'm going to subtract 1. So that gives me cosine theta is equal to negative 1. And here I'm going to add 1. So that'll give me cosine theta is equal to positive 1. All right, let's go ahead and look at a diagram and answer all of these questions. Okay, so here's my unit circle. And I'm going to look at the quadrantal angles for this. All right, I'm seeing the 1s, -1, 0. Those are all things that occur at the multiples of pi over 2. So here I have 1 comma 0, and then 0 comma 1, -1 comma 0, and 0 comma -1. So cosine is the x value. So for this first one, I want to know what angle will give me an x value of 0. So I see 1, I see 0 right here, I see -1, and then I see 0 right here again. So these are the two angles that give me a cosine of 0. So that means I have two solutions so far. All right, I have theta is equal to pi over 2, or 3 pi over 2. Okay, so I have two solutions so far. Okay, looking at the next one, cosine theta equals -1. So again, I'm looking at the x values and I'm looking for -1. No, no, yes, no. So this is the only place where I have a cosine that equals -1. So this angle is pi. So I have theta is equal to pi. So I have another solution. So now I'm going to look at the final factor. Cosine equals 1. So I'm looking for x values that are 1. Ding, 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 there's 1 right there. No, no, no. So this is the only angle that has a cosine of 1. And this is angle 0 right here, angle 0. So theta is equal to 0. So there we have 4 solutions to this problem. Pi over 2, 3 pi over 2, pi, and 0. All right, that's going to do it for this video. I'm going to make one more video where I wrap up the remaining examples that we have here to work with. So I hope to see you on the next video. We have plenty more to come.